All right, one last rate problem example. This is number 10 on, it would be page 34, I guess we're on now. And again, I've already worked it out for you. I hope you've read the problem. If not, I urge you to stop the video and do that now. It is another problem where we're using the formula distance equals rate times time. So that's going to help us set up our little chart, and it's going to help us write our equation. You've got two different kinds of planes. One's a private plane and one's a jet plane. It gives you information about how fast they're going. It gives you information about when they left. And the question is, how long will it take the jet, who's going faster by a whole lot, as a matter of fact, how long will it take the jet to pass the private plane? In other words, in how many hours are they going to meet? And then the jet is off to the races. So what's important here, when you set up your players, the plane and the jet, obviously you can fill in the rate in miles per hour, 150 and 600. What's important about the time is that you recognize this little statement right here. 1 hour later, a jet leaves. So the private plane leaves first, going pretty slow, and then an hour later, this jet leaves going really fast. So the jet is obviously going to catch up with the private plane, but his time when they meet will be 1 hour smaller than the plane's, because the private plane left an hour ahead of the jet. So you can do it adding one onto the plane or subtracting one from the jet. But this is the important part of this problem, recognizing that their times are not the same. And then, of course, you just multiply straight across, rate times time. Here's your rate times your time equals your distance in miles. So the plane, when they meet, will have gone 150 times x. The jet is going to have gone 600 times x minus 1, and we're doing some distribution here. I'm writing the distributed expression, 600x minus 600, and we've got our chart filled out. We set these equal to each other because the time is going to be the same when they meet. So the question is, this distance and this distance, we are going to solve for x. And x, I didn't write the let statement, but here's the x right here. Let x equal number of hours till they meet. So one's going faster than the other, but once you start that clock, that x going, when they meet, they both will have gone the same amount of time, since we took care of the x minus 1 over here. So when you set these equal to each other and you solve, you get 1.3 repeating. 0.3 repeating is the same thing as 2/3. So 1 2/3 of an hour is the same thing as 1 hour and 20 minutes. So in an hour and 20 minutes, that jet is going to catch up with the plane, and the plane is going to be left in his dust. I think this relates to one like number 9 on the practice. If I got that number right, this might help you when you're looking at that one on the practice. Okay, we're about done with these example videos, and we'll work some of these problems. Obviously, you guys will do some at home, and we'll do them in class as well. Bye.